All right. So for the people who are gone today, pause the video and write down these 3 vocab words on your vocab sheet. And then I forgot to record right at the start. So we found the distance between a couple points, A and B, by finding the average. And then we found the distance between C and D by finding the averages of the x's and averages of the y's. And then the midpoint. To find the midpoint, what we do is use the midpoint formula. So down here, we have these 2 endpoints. We have -4, -1, and 2, 1. So to find the midpoint, which they show is -1, 0, what we have to do is take the 2 x's. We put them together, -4 plus 2 divided by 2. Then take the 2 y's, put them together, -1 plus 1 divided by 2, which is -2 over 2, and 0 over 2, which is -1, 0, which matches their answer. So that's how we use the midpoint formula. Take the x's, add them up, divide by 2. Take the y's, add them up, divide by 2, and we get the midpoint. Pretty easy. So, what's the midpoint of AB? So, using the midpoint formula, what 2 numbers do I put here when I add them up, Elliot? From the picture, what 2 numbers will I put there for my x's? -3 and 4. What 2 numbers will I put here for my y's, Kyra? 2 and -2. So -3 plus 4 is 1. -2 plus 2 is 0. So it's 1/2 and 0. The point 1/2, 0 is right there. That is our midpoint. JL. One thing they didn't do for this one is they didn't tell us where J is and where L is. They have it on the graph, so we have to write down their ordered pairs. J is at 1, 2, 3 back, 1, 2 down, so it'd be -3, -2. L is 2 over and 3 down, so it'd be 2 over and 3 down, 2, -3. Now, we have to find the midpoint of that. So, what are your x numbers, Elizabeth? -3 plus 2. What are your y numbers, Ella? -2 and -3. So if we add these up, we get -1/2, -5 halves, and we just leave it like that. We don't change them to -0.5 and -2.5. You could if you wanted to, but -1/2, -5 halves is just fine. Okay. All right. What are the coordinates 3/5 of the way from A to B? Ooh. Now we're not doing the midpoint anymore. We're doing a little more math. We're doing 3/5 of the way. Okay. So we got to find how far it is from 3 to 13. How far is it from 3 to 13? It's 10 units long. Okay. How far is it from -4 up to 11? From -4 up to 11. How far is that? 15. Okay. So 10 and 15 are our distances for x and our distances for y. If we want to go 3/5 of the way from A to B, we take 3/5 of that. We take 3/5 of that. So we take 3 times 10, which is 30, divided by 5, which is 6. We take 3 times 15, which is 45. 45 divided by 5 is 9. Okay? The 0.69 isn't the right answer, though. That's how far we go. Okay? So then we have to do, this is how far we go in the x, this is how far we go in the y. So we take 3 plus 6, which is 9 for our x. We take negative 4 plus 9, which is 5 for our y. And the answer is 9, 5. 9, 5 is 3/5 of the way from A to B. So one more time going through that. The x value is 10 away. 3/5 of the x value is 6. So we have to go 6 away from 3 on our way to 13. 3 plus 6 is 9. So 9 would be our x value 3/5 of the way. From negative 4 to 11 is a distance of 15. So we have to go 3/5 of 15, which is 9. So you have to go 9 bigger than 4. 9 bigger than 4 is 5. Okay? So that's doing 3/5 of the way. All right. Distance. To do distance, we're going to use the distance formula. So this also goes on your note card. The distance formula is x2 minus x1. It's not x squared, it's x2 because we put the number as a subscript down below. x2 minus x1, and then we're going to square that plus y2 minus y1, and we're going to square that. So that's the distance formula. That goes on your note card. Make sure you get that on your note card. The distance formula. Okay, so the distance formula comes from the Pythagorean theorem. And the Pythagorean theorem comes from this guy by the name of Pythagoras, who's a Greek guy that lived like 600 BC. The dude was smart. Okay? The dude was so smart that people knew he was smart. So then he had a group of followers called the Pythagoreans. And they treated him like a god. And if anybody said anything bad about Pythagoras to the Pythagoreans, what they'd do is they'd load him up on their boat. Whoops, I didn't mean to do that. They'd load him up on their boat. They'd sail him out to the middle of the Mediterranean Sea. And they'd make him walk the plank. And they'd dump him over the side. Basically, they'd murder him. if they talk anything bad about Pythagoras. Okay? So Pythagoras is an important guy. And he had this Pythagorean theorem which said, in a right triangle, the hypotenuse squared is equal to the sum of the two sides of the right triangle squared. Okay? Otherwise known as c squared equals a squared plus b squared. For you guys, what we need to worry about is if we square each of these, if we take the two x's, subtract them and square it, we take the two y's, subtract them and square it, that should equal the distance squared. So the distance squared is equal to x2 minus x1 squared plus y2 minus y1 squared. But we want just the normal distance. So to get the normal distance, we take the square root of each side, which thus leads to the distance formula. So that is why we get the distance formula from the Pythagorean theorem. Now, we're going to try the distance formula out here. Okay, a pitcher throws a ball to a batter who hits the ball to the shortstop, and the ball travels in a straight line. Okay, so pitcher to the batter, straight line. Now the pitcher is at 0, or the pitcher is at 5, 5. The batter is at 0, 0. How far did the ball go from the pitcher to the batter? From P to B. Well, we take the distance formula. This is x1, this is y1. This is x2, this is y2. So you take 0 minus 5 and you square it, plus 0 minus 5 and you square it. 0 minus 5 is negative 5 squared. Negative 5 squared is 25, because negative 5 times negative 5 is positive 25. If we get another positive 25, that's the square root of 50. Now, they say round your answer to the nearest tenth of a foot. So on your calculator, put in the square root of 50. You should get like 7.1-ish? 7.07 to the nearest tenth is 7.1. So 1 unit equals 9 feet. So let's take 7.1 times 9 on your calculator. 7.1 times 9. So that's 63.9 feet. That's how far the baseball traveled from the pitcher to the batter. Now the batter hit it to the shortstop. So the batter is at 0, 0. The shortstop is at 5, 10. Okay. How far did the baseball travel from the batter to the shortstop? Well, batter to the shortstop equals the square root of x2 minus x1 is 5 minus 0. y2 minus y1 is 10 minus 0. 5 minus 0 is 5. 10 minus 0 is 10. What's 5 squared? 25. 10 squared? 100. So on your calculators, take the square root of 125. And I bet that's like 11.2-ish. 11.2. Take that times 9. 108. 100.8. So the baseball traveled 100.8 feet from the batter to the shortstop. Now the shortstop threw it to the first baseman. So the shortstop is at 510. The first baseman is at 10-0. Let's see how far the shortstop threw it to the first baseman. So S to F equals the square root of x2 minus x1 is 10 minus 5. Y2 minus y1 is 0 minus 10. What's 10 minus 5? 5 squared. 0 minus 10, negative 10 squared, which is the square root of 25 plus 100, or the square root of 125, which we just had was 11.2. Take that times 9. And the ball also traveled 100.8 feet that time. Okay? Going from the shortstop to the first baseman. Okay? So that is the distance formula. Let's do the distance formula one more time. Let's find the distance from K to L. What's the ordered pair for K? What's the ordered pair for K, Reese? One, 3. What's the ordered pair for L, Radley? 3, negative 2. So the distance from K to L equals the square root of x2 minus x1, which is 3 minus 1 squared, and then y2 minus y1, which is negative 2 minus 3 squared. So we take the square root of 3 minus 1 is 2 squared. What's negative 2 minus 3? What's negative 2 minus 3, Sawyer? Negative 5. So we get 4 plus 25 in a square root, which is the square root of 29, which rounded to the nearest tenth is 5.3-ish? I don't know. What is it? Square root of 29.
It'd be 5.4.
5.4 rounded to the nearest tenth. Okay? There we go. Okay, one more problem I want to do. So if 2, negative 1 is the midpoint, and A is at one end, what's the coordinates of B? If M is the midpoint of AB, and A is at negative 3, 3, and B is at 2, negative 1, or M is at negative 2, 1, the midpoint is at 2, negative 1, where would B be? Now you could use a whole midpoint formula to figure this out and work backwards and so on. Or we could do a little bit of logic to figure this out. Okay? If our x value is at negative 3 and halfway is at 2, how far did I go to get halfway? I went 5 to get halfway, right? So if I go another 5 to get the rest of the way, because if 5 is halfway, I have to go to another 5 to get the rest of the way, where should I be at? 7. Okay? How far is it from negative 3 to negative 1? 2. So if I go up another 2, where should that endpoint be? 1. So B would be at 7, 1. Okay? So if you're given a midpoint and an endpoint, to find the other endpoint, you just have to figure out how far you travel to get to the midpoint and then travel that much further to get to the other endpoint. Okay? All right. So that should be all you really need to know for the assignment. There'll be a couple tougher ones on this, so you just have to work your way through it. All right. So let me stop recording and